We're moving on to 7.2, which is transformations of exponential functions. We're going to start by applying transformations to sketch a graph. The difference here is that your base function will change because it'll be a different base every time. So what we need to do in these ones is we always need to look at our base function and come up with a table of values for that base. Then we can deal with a, b, h, and k and graph after. So before I can do anything with a, b, h, and k, we need to figure out what this original graph would look like. So y equals 3 to the power of x. This is an increasing function because 3 is bigger than 1. So remember, just like before, we'd plug in -2, -1, 0, 1, and 2, and then we'd go through and evaluate. So 3 to the power of -2, we'd end up flipping that and squaring it, so it would become 1 over 9. 3 to the power of -1, when we flip it and apply the power of 1, we get 1 over 3. 3 to the power of 0 equals 1, 3 to the power of 1 equals 3, and 3 squared equals 9. Then let's draw our base graph. So once we've graphed our base function, then we can take a look at a, b, h, and k. So when we're dealing with an exponential, you'd have your a, your c, your b, your x minus h, and then plus your k. So your c value, remember, is the base. In this case, the c value is 3. So again, I know that I have a 3 for a base. Then when I look, the b and the h are going to be in the exponent, because that's where the function, the x, is in exponential functions. So the b and the h are going to be up with the exponent of x. The k is going to be a constant at the end, and the a is going to be the leading coefficient in front of the base. So when I look at this, I see that I have an a value of 2 and an h value of positive 4. Again, be careful that in your original equation, h looks like x minus h. It's still negative, which means that my h value is a positive 4. So again, be careful with that h. So then let's talk about what this does. If a is 2, it's going to get taller by 2, and if h is 4, it's going to move 4 to the right. So this whole graph is going to get twice as tall and move 4 units right. So the easiest way to do this is probably with mapping notation, and in mapping notation I'm going to plug in some of my points. The key points to plug in are kind of those middle ones. So let's start with -1 and 1/3. So if I plug in -1 and 1/3, we get -1 plus 4 and 2 times 1/3, which gives me a point of 3 and 2/3. So 3 and 2/3 on my graph would be at 3 and 2/3, so we're going to go here. Now let's plug in our next point. Our next point was at 0 and 1. This should be an easy one. 0 plus 4 and 2 times 1 is going to end up at 4 and 2. So my y-intercept has moved to be at 4 and 2. And another nice point that we had was 1 and 3. So again, I'm going to plug in 1 plus 4 and 2 times 3 to give me a value of 5 and 6. So another point would be at 5 and 6.
Yeah.
And once we have our function here, we can come up with the domain, the range, the x-intercept, the y-intercept, and the horizontal asymptote. The y-intercept you have to be a little careful with because it's not very clear as to what the y-intercept is. So you can always find a y-intercept by setting x equal to 0 in your equation. And when you set x equal to 0, we'll get 0.025. Let's try another example to go along with this. This one also has a base of 3, which means we're going to use the same table of values from before. So again, we know the base function from before. I know my a is -1/2, so it's going to flip upside down and be half as tall. My b is 1/5, so it's getting 5 times as wide. And my k is -5, so it's moving 5 units down. So we can make the mapping equation and then plug our points in. Again, when I do this, I know that my points are going to be a little tough to graph, so I'm just going to use those 3 middle points. because those three middle points should be my easiest ones. So let's start with plugging in -1 and 1/3. So 5 times -1, and then we have 1/2, -1/2 times 1/3, subtract 5. And I am okay if you want to do this part in your calculator. So once we know our points, we can plot our values. So I'm starting at -5.5, or sorry, -5, and then -5.2. So it'd be somewhere like that. Another point I know is 0 and -5.5. And then I also know +5 and -6.5. So something like this. And so I also need to know, though, before I do this, I should figure out where my horizontal asymptote went. So you guys, the horizontal asymptote from the original graph was here on the x-axis. But this would have got flipped upside down. That doesn't matter. It would have got stretched 5 times wider. That doesn't matter. But then it got moved down 5. So my new horizontal asymptote is affected by the k value. So it actually moved down to be at -5. Now that should help us, because I know that my graph is going to hug that horizontal asymptote. So you're going to hit the points that you were given, and then you're going to go to hug that horizontal asymptote line.
Wait, how do you know that your horizontal asymptote?
So once we have our graph, then we need to come up with all of our information. So remember that here your x-intercept is still none. Your y-intercept, we already found that. It hits at -5.5. Your horizontal asymptote has been moved down to -5 with your rest of your graph. Your domain is an element of reals, and your range now is going to be less than -5 because it's going to be below the horizontal asymptote. Okay, so when we get into word problems, it's going to be really important to figure out what the base is. We can't really do anything else with the question until we know the base. So when you're thinking about how to find the base, always think, okay, is your function going to be increasing or is it going to be decreasing? Because it should be easy in a situation to tell if your numbers are going up or down. So for the first question, we're talking about population. Here we have the town of Smithville in 2003 was estimated to be 35,000 people. The rate of growth or increase was about 2.4%. So this one, we're increasing the population by 2.4%. So what would the base be? So again, if my growth rate is 2.4%, that means I'm increasing my population by 102.4%. The 100 represents the amount that you started with, and then the 2.4% is the amount that we're growing each year. So the C value would be 1.024. So again, in my equation, I'd get 1.024. And then since the 35,000 is representing the starting point, we're going to be multiplying by 35,000. So the 35,000 would be your A. We're also going to put an exponent of x on this, where the x would represent the years that are passing. So if I wanted to say, okay, what's the population in 5 years, I'd put a 5 in for x, and then it would do the 5-year growth calculation. So let's look at example 2. We're going to use transformations to model a situation. Here we have a cup of water is heated to 100 degrees Celsius. So I'm starting up here at 100 degrees Celsius. Then it's going to cool to room temperature in a room where the temperature is 20 degrees. So it's going to cool down to be 20 degrees. That's why we've got a horizontal asymptote there. The temperature T in degrees Celsius is measured every minute as a function of time in minutes, and these points are plotted on the coordinate grid. It's found that the temperature of the water decreases exponentially. That's going to be very important. It's decreasing at a rate of 25% every 5 minutes. So we're losing 25% every 5 minutes. We've got a graph here to take a look at what's happening. We're going to first figure out A, B, H, and K and our base value and put it into the equation. So if I'm losing 25%, that means I'm maintaining 75%, so C would be 0.75. I see that my horizontal asymptote moved up to 20, which means K is 20. Now let's look, okay, remember that 100 wouldn't have actually started at 100 if I shift the K back down. We would have actually started at 80. right? If I shift everything back down to where it should have been at the start, everything would move back down 20, so I would have started at 80. So that is going to tell me my starting point. And which letter, A, B, H, or K, is where your graph starts.
C.
So my A value then is 80. And now one more thing here, and this part is probably the trickiest. We actually have a B value as well. Now my B value is every 5 minutes. That means a graph that was normally in 1 minute intervals has now been stretched so that it's in 5 minute intervals. So the graph went from 1s to stretched to be 5s. What's my value of B? 1/5. Good job, you guys. So again, my x-axis stretched to be 5s instead of 1s. So now we can put this all into our equation. So it's going to be y equals 80. The base is 0.75. The b value is 1/5. There's no h value, and the k value is plus 20. So that would be your equation. So check your answers here for part B. It's just going through how we figured out A, B, H, and K. And then you can go ahead and work on those textbook questions.